apparatus, and a glass rod for mixing. Measuring mass. Use digital balance. Balance should be tiered, set to 0 to avoid zero error. Balance should be allowed time to settle before reading recorded. Measuring volume. Burette, most accurate. Read burette scale from top to bottom. Volumetric pipettes, most accurate way of measuring fixed volume. 10 cubic centimeters, 25 cubic centimeters. Measuring cylinder, not very accurate, used for approximation. 10 cubic centimeters, 1 liter, 1 cubic decimeter, 1,000 cubic centimeters. Measuring gas, gas cylinder, most precise and accurate way. Downward displacement of water. Measuring cylinder is inverted in water to collect gas. Does not work if gas is soluble in water. If gas is heavier than air and colored cylinder doesn't have to be inverted. First few bubbles are ignored as it is air. To ensure that no gas escapes, use a divided partitioned flask and tip flask to start reaction. Measuring temperature. Traditional thermometer, more accurate. Digital temperature probe, more precise. Can be corroded by some reagents and expensive. Indicators. Indicators are used to show endpoint in reactions. Indicator? Color in acid. Color in base. Color in neutral. Litmus solution. Red, blue, purple. Red litmus paper stays red, turns blue, no change. Blue litmus paper turns red, stays blue, no change. Phenolphthalein, colorless, pink, colorless, thymolphthalein, colorless, blue, colorless, methyl orange, red, yellow, orange. Substance, safety. Substance, precaution. Safety measure. Ammonia is toxic/poisonous. Fume vent cupboard mask. Chlorine gas is toxic. Fume vent cupboard mask. Ethanol is toxic/very flammable. Keep away from heat. Lead salts is toxic. Take care. Sodium hydroxide is hazardous/irritant/caustic. Boiling will cause mixture to spit, blow out, so warm carefully. Other important colors. Substance, color, fluorine gas, pale yellow, chlorine gas, pale green, bromine liquid, red, brown, orange, iodine solid, gray, black, brown, and AQ, copper metal, brown, silver metal, metallic gray, color of salts in solid form, color of salt, cation, present white solids, form colorless solutions. Na plus, Ka2 plus, Mg2 plus, Al3 plus, Zen2 plus, Pb2 plus, Ba2 plus, Ag plus, NH4 plus, pale green, Fe2 plus, green, Ni2 plus, and Car3 plus, yellow, brown, Fe3 plus, blue/pale green, depends on compound. Q2 plus common errors and improvements. Errors, improvements, no repeats. Repeat at least thrice and take average. Hard to judge endpoint. Use colorimeter. Measuring cylinder inaccurate. Use burette. Adding past endpoint. Add volume in smaller quantities. Temperature, heat loss. Use a thermostatically regulated water bath. Graphs. Independent variable on x-axis and dependent variable on y-axis. Questions. Why does the graph level off? The reaction is finished and all of named reactant has reacted, been used up. Why must graph pass through origin? It is because when no named reactant is added, there is no reaction. 6 marker, planning and investigation. Specify the volume/mass/etc. State apparatus in which reaction takes place. For example, beaker, conical flask. State measuring instruments. For example, burette. Volumetric pipette, measuring cylinder. State constant variables. Fair tests, if necessary. For example, in titration, neutralization. State a conclusion. Frequently asked questions. What is a saturated solution? Yeah, a solution with the maximum concentration of solute dissolved in the solvent at a given temperature, or solution that can dissolve no more solute. Explain why it would be an improvement to measure using a burette. Be more accurate. Explain why it is not possible to use a volumetric pipette to measure volumes. The volume is not constant/fixed/not the same in every run. How to check if liquid is pure water. Check boiling point, exactly 100 degrees Celsius. Or melting point, exactly 0 degrees Celsius. Why is it important to immediately put a bung in the conical flask where gas is produced? To minimize gas loss escape before bung is replaced. Describe additional measurements that need to be taken to determine whether the reaction is endothermic or exothermic. Measure the temperature before and after the reaction. Why use a partition flask? So the reaction can be started by tipping container. Do not have to remove bung. So no gas is lost, escaped when bung is removed. Describe how a Bunsen burner is adjusted to make the flame as hot as possible. Air hole must be fully open. State the advantage of measuring volume of gas collected every 10 seconds rather than every 20 seconds. More points, data, so better, smoother graph. Which flask is used in distillation? Round bottom flask. Why are anti-bumping granules used in distillation? To reduce size of bubbles formed when liquid boils. Used for safety to stop flask from shaking. What is the purpose of water or condenser in fractional distillation? Of mixture of alcohols. To condense the vapors from gaseous to liquid state. In distillation, why is the thermometer placed in that way? To measure the temperature of the vapors as the temperature of the liquid is not constant. Why would carrying out an experiment in a polystyrene cup rather than a boiling tube or glass beaker improve accuracy of results? Polystyrene is a good insulator, so it reduces heat loss. Why is it not a good idea to heat something in a polystyrene cup? It will melt. Advantage of measuring cylinder. Quick, easy to use, convenient. Disadvantage. Not accurate measurement. What will happen if gas continues to enter a closed conical flask with liquid inside of it? Liquid will be pushed out of flask. In a reaction where gas is produced, how does the results show that the reaction is over? Gas volume constant/stay at final volume of gas. Suggest why the mixture in the beaker was stirred as it was heated. To speed up dissolving. Explain why the conical flask was swirled as acid was added from the burette. To mix the content. Explain why the conical flask was not rinsed with solution L. It will add an unknown volume of solution L in the flask. State why using 50 cubic centimeters of solution L would cause a problem. It is more than can fit into burette. State the temperature of the mixture after 2 hours. Room temperature, heat loss to surroundings until mixture solution is equal to environmental temperature. Why was the residue rinsed? To make sure all the filtrate goes through. No filtrate left behind in the filter paper. This will increase yield. To wash out, dissolve, remove salt. Explain in terms of particles why the rate of reaction was greatest in this experiment. More particles per unit volume. Greater chance of collisions, so more frequent collisions. Suggest and explain a disadvantage of using a graduated pipette instead of a measuring cylinder to measure solution. Too slow, slower addition of solution takes longer to add. Measuring time taken less accurate results less accurate. Suggest how a sample of copper could be obtained from the solution of copper to nitrate. Add more reactive metal like magnesium. Magnesium displaces copper and solid copper is formed and can be filtered. Why is it necessary to gently heat the solid in the tube first? Solid spits out of tube/the tube might crack. Why is the burette washed with I, distilled water, and 2, acid added? I, to remove residue impurities. 2, to remove traces of water/ so acid is not diluted. Why is solid in excess? Preparation of salt. To ensure that all acid has reacted. This is done to avoid leaving any unreacted acid, which would become dangerously concentrated during evaporation and crystallization. Define in excess. Unreacted solid that has not dissolved. Insoluble. Describe how to conduct a flame test. Heat nichrome wire. Use concentrated hydrochloric acid to wash nichrome wire before and after use to remove residue. Dip the wire into the salt to be tested. Hold sample into hot flame. Describe flame color. Explain why a yellow flame is not suitable for a flame test. B. It is not hot enough. Masks the color caused by metal ion. When a solid substance has no obvious cation, it is probably a transition metal. Is a catalyst for the other reactions occurred. How would results be improved by taking repeated measurements? It can spot anomalies, and an average mean can be taken which is more reliable. Suggest how reliability of results could be checked. By repeating experiment and comparing results, or by taking an average. Why must electrolosing object be very clean and free of grease? So that coating will not stick, be even. Dirt or grease will be trapped. For an experiment with dV of time taken for text to become visible. I. What would be the change in results if narrower and taller beaker was used, and D2. Explanation. I. Time taken longer. 2. Due to greater depth of liquid. Explain why cotton wool is placed in the neck of a conical flask. To prevent splashing, escape of acid. To allow gas to escape. Suggest why small glass beads are used in fractionating column. Larger surface area, so it causes higher boiling point liquids to condense and fall back into flask more effectively. To test for presence of water. Anhydrous copper sulfate water. Exothermic. Temperature increase. Color change white to blue. Cobalt chloride water. Endothermic. Heat is applied for color change. Color change blue to pink. Chromatography. Why is the baseline drawn in pencil? Pencil is insoluble in solvent. Possible solvent. Water or organic solvent, for example ethanol. Why does the mixture on the baseline of chromatography not move sometimes? Compound is insoluble in given solvent. Why are there only 2 spots seen from a mixture of 2 dyes? Due to same RF value. What happens when the initial level of solvent is above baseline? The solvent will dissolve the compounds and the compound will not migrate effectively. Electrolysis. Mention for question 4. Inert electrodes of graphite/carbon/platinum. Product at each electrode. Electrolyte. Definition of electrolysis. How to carry out titration? 1. Measure known volume of alkali into a conical flask. 2. Using pipette. 3. Methyl orange indicator added. 4. Add hydrochloric acid. 5. From a burette in small portions, and stir as each portion is added. 6. Mix swirl. 7. Until indicator changes color. 8. Record calculate volume acid added. 9. Repeat with same volume acid without indicator. Errors in titration. Going past endpoint. Using measuring cylinder. Only carrying out experiment once. Improvements. Use burette in place of measuring cylinder. Add more slowly. Repeat and calculate mean. Preparing salts. How to form hydrated crystals from aqueous form. 1. If reactant is in excess, filter to obtain only the liquid product. 2. Heat to saturation crystallization point. 3. Allow to cool. 4. Dry between filter paper absorbent paper. How to form anhydrous powder from aqueous form. 1. If reactant is in excess, filter to obtain only the liquid product. 2. Heat. 3. Weigh solution. 4. Reheat, reweight, and repeat until mass is constant. How to prepare insoluble salt. Formed by a precipitation reaction, also called double decomposition. 1. Filter solution, NaI. 2. Wash the residue with distilled water to remove any residue, for example, soluble salt. 3. Dry between filter paper.